study in our previous lecture that what is charge basically. So in this lecture I will gonna tell you what is actually Coulomb's law. We'll study what is Coulomb's law. So let's start. So Coulomb's law. So in our last lecture, basically we learn about the charges. So we say that if we put two charges, unlike charges in a free space, they will experience a repulsion. And if you put two unlike charges, they will experience a attraction. So basically what is the repulsion and attraction? It's a force, right? Force. So Coulomb's law is for force, means how to find the magnitude of that attraction and repulsion, that state by Coulomb's law. So what it is state that means it states if two point charge placed in space, the force experienced by the two charge due to each other is proportional to magnitude of each charge and inversely proportional to the distance to the square of distance between them. So basically the पे क्या बोल रहा है कि means if we put two charges, let's say positive and positive, and Q1 and Q2. Okay, I will write that for space. Okay, so if you put two charges in a space and let's say the distance between them is r. So what will be the magnitude of the forces experienced by those two charges due to each other? So the magnitude of these two forces is given by Coulomb's law. So let's say this what according to Coulomb's law, we know that the force, what Coulomb's law states, force is magnitude, actually magnitude of force. Force is a vector quantity, so we consider only magnitude. The magnitude of force is directly proportional to the Q1 and Q2. So this is our equation number 1. So next thing that Coulomb says that magnitude of force is directly proportional to the inversely proportional to the 1 by r square. Means r, what is the r? R is the distance between those two point charges in the space. So this is our equation number 2. Great. Now if we combining these two equation, if we combine equation 1 and 2, if we combine this equation, we can write that magnitude of force is directly proportional to the Q1 Q2 divided by r square. Okay, Samjha? Now, so for remove that proportionality sign, we add a constant. So we can write magnitude of force is equal to a constant k, Q1 Q2 divided by r square. Great. Actually, this is the Coulomb's law basically. So here you can see this force is somewhat related with gravitational force that we have seen. So in our gravitational chapter, so as like gravitational force, what is it? G m1 m2 divided by L. Both are in inverse square law. So you can also say that Coulomb's, it says Coulomb's inverse square law. Square law. Okay, because it is inversely proportional to the square of the radius between them. Okay, great. So what is the difference? Mainly difference this is actually electrostatic force. Electrostatic force. Okay. So what is the main difference? Main difference is in constant. That is an universal constant. That means in every places the G will be same, remains same. But here K, that K is not a universal constant, that depend on media. Means that where we put that two charges is depend on this medium. Let's say for this the K is 1. For another system the K will be something like 2. Okay, so it's depend on medium to medium. Okay, unlike gravitational force, universal gravitational constant. Okay, great. We now discuss what is Coulomb force. And now we're gonna see, this is a force, right? So what is the direction of the force, we don't know. So now we'll see how this force act and in which direction is force act. So Coulomb also says, I'll draw. So Coulomb also says that the force acting on each body, that charge, each body is along the line joining the two center of that point two charges, 2 point charges. Okay, so the force on this charge due to this charge is in that direction. So force on charge 1 due to charge 2. Okay, so similarly in that case the force on charge 2 due to 1, charge 1 is in that direction. Okay, because that is positive and positive, that is positive and positive, and it will repel each other. So force will be acting in opposite direction. So we can write that, accordingly we can write that force 1 2 is actually equal to minus of force 2 1. Okay, that is basically what Coulomb state in that. So now we know the magnitude, now we know the direction. So for direction, force is a vector quantity, right? So we just find the magnitude. So what is the direction, we also know. So if we write the force in a vector form, so what will be that? Vector form of Coulombic force. So हमने बात किया था कि Coulombic force और इलेक्ट्रोस्टैटिक फोर्स एक ही है, नाम में डिफरेंस है, कुछ नहीं है. So Coulombic force is also called as electrostatic. याद रखना, electrostatic force same ही है. So we know the magnitude of the electrostatic force and we know the direction analytically. So we will now form that we will convert this force in the vector form. So how we convert that form vector form, we will see in now. We will see in 2 minutes. We now going to form a vector form for this force. So let's consider a space, 3D space or whatever you consider. Let point charge Q1 here, and the radius vector for that is R1, and let another charge Q2 be here, and radius vector is R2, right? So we need that distance, right? And you know the vector sum, vector subtraction, everything. So how how will you find that the distance radius? So basically we know that force is acting that side and that side, considering plus charge. So force on 1 due to 2, force of 2 due to 1, right? So what is that? If you studied the vector in class 11, then you will know that this is nothing but R1 minus R2 if it is directed in that direction, and R2 minus R1 if it is directed in that direction. Okay, great. That is, we get that vector form. Now, the force we know the magnitude. Magnitude we know force is given by K, Q, 1, Q2 divided by R square. Mod of R square actually. That mod of R is basically R2 minus R1. Okay, great. Understood? Now, I will draw that. Okay. So we know that magnitude of force and the direction also. So how can we find that vector form? So we know that every vector is having its magnitude and its direction, right? That did not like that. That is actually unit vector. For direction we use the unit vector. Okay, so we know the magnitude of force also. That magnitude of force is K, Q1, Q2 divided by mod of R square. And what is the magnitude of direction? Means unit vector that is going to use in that force. So the unit vector is basically R2 minus R1 divided by R2 minus R1. Mod of R2 minus R1. That is only the unit vector. Okay. So we can write F12 is equal to K Q1 Q2 divided by mod of R square into mod of R2 minus R1. R2 minus R1. Okay. So that is nothing but what? Mod of R. We define like that. See. So what we can write? So what we can write? F12 is basically K Q1 Q2 divided by mod of R cube into R2 minus R1. Right? That is the vector form of that force. That is the vector form of that force. Now we are going to see some questions based on that. So before that, I'm forgot to tell some points. So let's discuss it. We know that force is a inverse square law of force, right? So directly proportional. So how we can show that in graphs? So let's draw a graph that is force and that is distance or radius, whatever you say. So how the graphs looks like? So as the distance is increasing, the force value is reducing. So the graph seems like to be that, somewhat like hyperbola. So that is the point I missed. So now let's do some questions based on that. So clarify our concepts regarding that Coulombic force. So let's do some questions. So we'll gonna discuss this question. So what that question says, basically we are given a charge body of charge q and they divide it in two parts, that is part 1 and that is part 2, and they're saying that they put these two part at some particular distance. Okay, So after putting that two part at some particular distance, they find that the force is maximum. So we have to find the charge. We have to find the charge on each particle so that the force is maximum. So what we are gonna do, I will show in presentation. Means after doing it, let that after cutting that, let the charge be here is x. So according to the conservation of charge, what will be the charge in here? That is obviously q minus x, right? So the charge is over here is x and the charge of another part is q minus x, and we put at some distance r, right? I don't know what about the distance. I don't know about the distance. What is r? So here this is that the force must be maximum. So according to the Coulomb's law, what will be the force K Q1 Q2 divided by r square, which is equal to K. Q1 is x basically, and Q2 is q minus x divided by r square, right? So now our force is a function of x, right? So if you know the differentiation and finding the for finding maxima and minima in differentiation, we use for finding a maximum or minimum point of a function, we use differentiation. So if you have a function like that, obviously if you find the maximum point, we have to differentiate, and if after differentiate, if we get the value differentiation of function with respect to x is equal to 0, then it will be the our maxima or minima point based on the function. Okay. So similarly, we are going to perform differentiation over f with respect to x. So how much charge should be in the other part such that the force is maximum? That is what we are going to find. Okay, so df by dx, if you differentiate it, I'll put separately. Okay, x cube divided by r square minus k x square divided by r square. So if you differentiate it, what will you get? K cube divided by r square minus 2kx divided by r square equal to 0, right? So k gonna cancel, and okay, k gonna cancel, r gonna cancel, so q should be equal to 2x. Therefore x should be equal to q by 2. So basically what we get, x equal to 2. So basically when we divide the charge in two equal parts, then we have the force will be our force will be the maximum. Okay, so that is over. Now I am going to another question of that topic. Understood? So the point is, if we divide the charge equally in two parts, then we have maximum force, right? So हमेशा याद रखना कि अगर मैक्सिमा या फिर मिनिमा का क्वेश्चन पूछा है तो हमने डिफरेंशिएशन करना है. We're gonna learn about the superposition theorem. Superposition theorem. So basically what it says, suppose मान लीजिए आपके पास तीन चार्जेस है, Q1, Q2 and Q3. So इस चार्ज में इन दोनों चार्जेस के लिए कितना नेट फोर्स लग रहा है. सो पहले हम लोगों को पता लगाना है कि हर एक चार्ज के लिए हर एक में कितना लग रहा है. ठीक है, तो इसमें इसके लिए कितना लग रहा है, फोर्स 1 3. Okay, then force in that charge due to this one is in that direction, that is force 1 2, right? So superposition theorem, what it state? It state that the net charge acting on any charge, net force acting on any charge is the total vector sum of every force due to all other charges. Means सराउंडिंग में जितना भी चार्जेस होगा उसके वजह से इस चार्ज में जितना भी फोर्स लग रहा है उसका जो वेक्टर सम होगा वही होगा उसका नेट चार्ज, वही बोलता है सुपरपोजिशन थ्योरम. सो लेट्स राइट दैट. इट स्टेट्स दैट द net force acting on any charge is equal to the vector sum of all forces due to vector sum of all forces on it due to all other surrounding charges. सो एक एग्जांपल लेता हूँ, इससे आप लोग अच्छे से समझेंगे. सो बेसिकली आई विल रब दैट, देन आई विल टेक एन एग्जांपल दैट विल क्लियर इन कॉन्सेप्ट्स रिगार्डिंग दैट पर्टिकुलर कॉन्सेप्ट. सो लेट्स टेक ए इक्विलेटरल ट्रायंगल. दिस इज एन इक्विलेटरल ट्रायंगल ऑफ साइड A, right? Okay, I put charge here, charge over here, charge over here. Both, all of the three charges have same magnitude of Q. Okay, and the distance between them is A. So we have to find the net force on that charge. So we know that the angle between them is 60, right? So let's put 1 here, that body is 2, that body is 3. So the force on body 3 due to the body 1 is what? F31. Okay, and the force directed to in that direction, and force due to body 3 force on the body 3 due to this body 2 is acting in the direction, that is F32, right? So we'll find the magnitude first. So F32 magnitude of that is K Q square divided by A square, right? F31 is equal to K, it is also equal to like that, right? Now we know that the angle between them, that is 60 degrees, because it is a equilateral triangle, right? So we need the vector sum of that two forces, right? So how we can find that vector sum? We know that the vector sum, we can write like that: magnitude of net force. If you study the vector, the net force is F1 square plus F2 square plus 2F1 F2 cos theta, and theta is the angle between those two forces. That in our case it is 60 degree, right? So we know that our magnitude of F32 and F31 is same. So we take the common, means let's take both of equal to F, right? So F square plus f square plus 2 f into f equal to f square into cos theta is 60 degree. So cos theta equal to 1 by 2, right? So what we will get 3f square. We will calculate. That will be root over 3f. So I will write that and its space. Okay. So the magnitude of net force acting on that charge Q. That charge due to this charge here, charge is there, due to this charge is mod of f equal to root over 3f, where f equal to k q square by s square, right? So root 3 k q square by s square will be the answer. Okay, so how we will do that? Using superposition theorem. At first we calculate the force of that particular system, and then separately or independently, we can say independently we find the force of that particular system, and then we just add vectoring. Okay, so that is our superposition theorem, and now we are going to have some questions regarding that superposition theorem for better understanding of that concept. So now we are going to do a questions based on superposition theorem. So here in this question, if you read that question, it is given that we have two charges, one charge q and q, right? And the distance between them is r, and we put another charge of q by 4 in midway, means that r by 2 from both the charges we put a charge q by 4. So before putting that charges, we have the force on this body. Force on this body is F. F. Okay. So after putting that charge, what will be the net force on this body? We have to find that. Okay. So at first we have to calculate what is the force F in initial condition. So initially force F equal to k q square by r square. ओके, पहले हम लोगों के पास फोर्स F इतना था. आफ्टर पुटिंग दैट चार्ज इन मिड वायर, what will be the forces? We have to calculate using the superposition theorem. So both the forces will act in that direction. That is for force on this body due to this point charge and this point, both that forces will be act in same direction. So we'll just add it for finding the net forces. Okay, so at first calculate that the force due to the force on this body due to this charge. Okay, so that is already we have find, that is k q square by r square. Now we are gonna find what is the force on this body due to this charge. Okay, so find and then add, that is k q square by 4 divided by r square by 4. That will be the net force acting on this body. So that will be the F net, right? So if you calculate that will you get 2kq square by r square. Now our F is let's say is F prime. F prime is that, and initial condition we have F equal to kq square by r square. So what is the force in terms of means F prime in terms of F. So we just divide that F prime by F equal to What is F prime? That is 2q kq square by r square divided by kq square r square. Cut it and we get F prime equal to 2F. So that is the answer. So what is the force F now? That is basically F prime equal to 2F. Now the force is 2F. So one last topic we remind here, that is limitation of Coulomb's law. So first limitation is it is only applicable for point charges. It is not applicable for the extended body charges. Like if you have some spherical body and if you have your charge is equally distributed over there, and you want to find the force between these two bodies, then it is not possible, it is not applicable. Means using Coulomb's law you can find for force between these two bodies. So it is right there, it is not applicable for extended body charge, right? So Coulomb's law basically we apply for a point charge. Second thing, if two point charges are at motion, means अगर कोई दोनों चार्ज, दो चार्ज हम लोगों के पास पॉइंट चार्ज है, दोनों चार्ज ही मोशन में है, तब हम लोग कॉलम्स लॉ को अप्लाई नहीं कर पाएंगे. इन द केस मीन्स अगर दोनों में से किसी एक चार्ज रेस्ट में होगा तब हम लोग कॉलम्स लॉ को अप्लाई कर पाएंगे. बट इफ टू पॉइंट चार्जेस आर एट मोशन, बोथ आर मोशन, मीन्स 2 point charges both are in motion, then we can't apply the Coulomb's law over there. Okay, so that's the point I want to make clear to you. So let's take another example that will let's grab it. So consider you are given a square, right? If in that square every corner point is charged with, we put a charge in corner of square, that is QQ. For every corner we put the equal charge, right? So we know we need to find the net force on the charge Q put in the center. You can take any charge Q, put in the center of that square. Okay, so what is the force, net force on that? If you use your some logic, that for this charge it will experience force here, for this charge it will force experience here, considering all charges are positive. So these two forces cancel each other because the distance is same for these two, right? And for these two cancel each other because the distance is same. So net force on that charge Q put in the center of the square is 0, right? So basically the point is, for any symmetrical body, अगर कोई भी symmetrical body होगा, and for any symmetrical body, if we put a charge on its center, of symmetry, the net force on that charge is equal to 0, right? और एक एग्जांपल से मैं आपको बताता हूँ. ओके, सो द एग्जांपल एक ले लेते हैं. एक स्फेरिकल बॉडी है, मान लीजिए यूनिफॉर्मली डिस्ट्रीब्यूटेड चार्ज है. ओके, सो इसके सेंटर में कितना चार्ज रहेगा, मीन्स कितना एक चार्ज रख दिया पॉइंट चार्ज क्यू इसके सेंटर में, तो वो पॉइंट चार्ज कितना फोर्स एक्सपीरियंस करेगा हमको मालूम करना है. सो इफ यू टेक ए स्मॉल पोर्शन ऑफ दैट चार्ज, लेट्स से इज डी क्यू. सो फॉर दैट डी क्यू, what will be the force experienced by that q charge? That is k dq q divided by let's say the radius is r square, right? For same diagonally opposite side, for same body that are diagonally opposite, we have charge again dq that will exert a force in opposite direction, right? That is also k q dq by r square. Okay, so that two force cancel each other. If you take any charge, any elementary charge on that spherical surface, it will having its diagonally opposite charge element also. So that will cancel each other and the net force will be the 0. So for a symmetrical body, the net force experienced by the charge put in the center of symmetry is equal to 0. Okay, thanks.